Okay, that one's zinging at me. All right, so today we're going to kind of wrap up our factoring unit and put it all together. We did a good job putting it all together yesterday with factoring completely, and I think y'all did a good job with that. So those 4 steps to factoring are still going to be a major thing of what we do today. Before we factor anything, what should we do first? Greatest common factor, then what do we do? See how many terms we have, right? See how many terms we have. If it's a binomial, we check to see if it's a difference of squares. If it's a trinomial, we make a, how do we factor with 4 terms? Grouping. What's our very last step to factoring? Check your binomials and see if there's any differences of squares or see if there's any GCFs. Okay? Very good. So that's the whole thing. That's all you need to know about factoring. If you know how to do all that stuff, then you're always going to know what to do. All right, so today we're going to solve equations. Now, what's the difference in just factoring an expression versus an equation? An equal sign. So that's how you know you're going to have to solve it if you have an equal sign. So we have talked about these words before back when we were learning about functions, I think. Do y'all remember graphing functions in our graphing calculator and seeing where they cross the x-axis? Y'all remember that? We called those finding the zeros, right? So what we're doing today when we're solving equations by factoring is we're essentially doing the same thing. We're just doing it with algebra instead of with the calculator. Now, there's going to be some that I'm going to want you to check with the calculator, so that's why we have our calculators out, okay? So I will show you that you're just seeing it in a different way. Graphing is one way to look for zeros, but algebra is another way. Algebra is more accurate, especially when you have zeros that are like 2.5 or something else that's a decimal or a fraction, because we can't really pinpoint unless it's an integer where it's crossing the x-axis on a graph if it's not at a whole number. Does that make sense? So that's why algebra is important. Now, we're going to learn a bunch of other ways in the next unit that we'll start next week, the quadratic unit, on how to solve these polynomial equations in other ways besides just factoring. We're going to learn the quadratic formula, completing the square, and some other ways. Okay, so we have talked about before how we have all these different names for the answers to a polynomial equation. Sometimes they could be called solutions. They could be called roots. We'll see next unit why they're called roots. They're called zeros and x-intercepts. So zeros and x-intercepts are the ways we have seen them before when we were talking about the zeros of a polynomial in a graph. Okay? Because x-intercepts, obviously, because that's where they cross the x-axis. So that is one way we can kind of check our answers too, is after we have solved it by factoring, we can pop that polynomial in the graphing calculator and see if we're indeed crossing the x-axis at those locations. Okay, so it's a good little way to check yourself if they're small numbers. So before we solve an equation by factoring, we want to make sure we are equal to 0. We don't want to be equal to any other number or variable. We want to be equal to 0. That is very important. So that's step number 1, is to get our equation equal to 0, and then we'll be ready to factor. Okay? So example number 1. 2x squared plus 8x equals 0. All right, is our equation equal to 0? Okay, so after you get it equal to 0, you just kind of ignore the equal sign and the 0 for just a minute. Just ignore it. Okay, so we're solving by factoring. Look at these 2 terms. Does it have a GCF besides 1? What is the GCF? 2x. 2x. So you're going to factor out a 2x. Parentheses. What multiplies times 2x to get 2x squared? X. Plus what times 2x equals 8x? 4. Close your parentheses. Keep your equals 0. Now, is it factored completely? Well, that's a binomial. Is it a difference of squares? No, so it's factored completely. Okay? So after you have factored it completely, you're going to set all of your factors equal to 0. Set all factors equal to 0. So what factors do I have? What's a factor? 2x is a factor and x plus 4 is a factor. Y'all see that? Okay, so you set 2x equal to 0. And you said x plus 4 equals 4. Set all of your factors equal to 0. And then you're going to solve both of those little bitty baby equations. They're baby ones. How do I solve for x for 2x equals 0? Divide by 2 on both sides. And what's 0 divided by 2? 0. So x equals 0 is one of my solutions. And then, how do I solve x plus 4 equals 0? Very good. Both sides. X equals -4. Okay? So we got two solutions. So that's how you do it. You factor it completely, then set all your factors equal to 0, and solve all your little baby equations. Now, I want to check it in my calculator just to show you how these go together. So, turn on your calculator. I got my old dinosaur calculator too. It's okay. All right, so on my calculator, do y'all remember how to graph stuff? Vaguely? Y'all remember what you're going to hit first? You're going to hit y equals. Y equals. And make sure it's cleared out. If you want a good blank y equals screen. All right, so what you're going to plug in was your original polynomial before the 0. So you're going to type in 2x squared plus 8x. So 2, and remember the x is right there by the green alpha button. 2x squared, and the square is diagonal from the 7, plus 8x. Get another one. Which one is that one? Okay. Hit graph. After you have that entered, hit graph, and you should get a parabola. Boom, boom. Raise your hand if you don't have a parabola that looks like mine. Everybody got one? Mm-hmm. I fixed you. What's wrong with it? Well, I don't think it's tip anymore. I've already tipped this fish that she had extra, and I think it's 10.
Can I have a serial number then? When do you put it on the ticket?
I'll put it on the ticket.
Okay, so if it's on the ticket.
Yeah, if you need it, you can have it.
No, that's fine. I won't get up there.
Okay.
So he ordered it was like $12 for 3 of them in the ring. So you think it's the same thing we did already?
Yeah, I think
Miss Hetfield, I mean.
I think it sounds like it's doing my heart. It's glitching. It's like it'll
You keep riding. It stops, starts, starts.
I can't even teach classes. So I've got to see what I got today. You want to see that?
Can I take the new one with me?
Yeah.
Or,
Well,
because last time when I was chatting with Lenovo, they were like, try this, try that, and I hate to tell them I don't have it with me, but
You want me here today?
for a little bit.
Here, you want to take it with you and bring it back to me? Let me see.
Yeah.
Sign.
You know what? Let me leave it there. I'll come back to get it because I got about 3 tickets to take care of. And,
Okay. I'm going to teach with this today, so it's okay.
When I'm finished, I'll come back to get it.
All right. Thank you.
Thank you.
Okay. So you see here how we got the solutions 0 and -4. Where are we crossing the x-axis? At 0 and -4. So isn't that cool? So that's one way we can check ourselves. So we plug it in originally where it was equal to 0, and it should work. Now, y'all, that only works when our solutions are small whole numbers. Okay? If they're fractional, then that's going to be hard to tell. But you can kind of tell if it's 9/2 for our answer, that's 4.5. So I should be crossing some over here at 4.5. Does that make sense? So you can kind of like estimate and check it, but it won't be as accurate if you have fractional answers or if you have numbers that are bigger or smaller than -10 and +10. Okay? Okay. So I'm just going to show you all that correlation. All right, number 2 has a hint to it. 6n squared equals 15n.
Are you the one that gives him
Okay, so second mode. The mode button is right by the second button. Second mode goes home. Okay, so is this one equal to 0? No. So my first job is to get this one equal to 0. And the way we need to do that is always move the smaller exponents to the larger exponents. So 6n squared is bigger than n, isn't it? So we want to move the 5n or 15n to the other side. So how do you think we mathematically move 15n to this other side? Mathematically. Subtract it. Good. So we subtract 15n on both sides. And these are not like terms. All right. Okay, we're equal to 0. So now we factor. Do we have a GCF in those two terms? What are they? 3 and n. Y'all agree? So 3n is the GCF. Parentheses. What times 3n is 6n squared? 2n. Minus what times 3n is 15n? 5 equals 0. Is that factored completely? Yeah, 2n minus 5 is not a difference of squares. So then we set each factor equal to 0. So we say 3n equals 0. And we solve both little bitty equations. So divide by 3. What's 0 divided by 3? 0. And how do we get 2n minus 5 equal to 0? How do I solve that for n? Add 5. So 2n equals 5 and divide by 2. So n equals 5 over 2. Leave it improper, but we know that's 2.5, don't we? So if we're checking that in our calculator, we should be crossing at the origin and at positive 2.5. Okay, so we're not going to check that one. I'll let y'all check later on your own time. No. Now, if I'm doing a test, I might check it, but you put it in the calculator. Graph it. Exactly. You would put it in. You would type it in where it was equal. Sorry, my scroller. You would type in this one where we got it equal to 0. And your y equals. Yeah. You always want to type it in for where it was equal to 0. Yeah. Number 3. We're solving this equation by factoring. What do we need to do first? Yeah, we got to get it equal to 0 first. So we're going to subtract 9 everywhere. So that's going to be 16x squared minus 9 equals 0. Okay. The reason that equals 0 is because there's nothing left over here after we move the 9 over. All right. 16x squared minus 9. Does that have a GCF besides 1? No. But what is it? It's the difference of squares. Everything here is a square, that's a square, there's a minus, it's the difference of squares. So factor a difference of squares, we make 2 binomials. Keep your equals 0 out there. We got to keep it mathematically correct, so we're dragging on that equal 0 all the way down. And what multiplies times itself to get 16x squared? 4x in the front. What multiplies times itself to get 9? 3 in the back. What goes in the middle of difference of squares? Plus and a minus. All right. Is that factored completely? Yes. So how do I solve it? Set both factors equal to 0. And I don't have room below, so I'm going to come up here again. So 4x plus 3 equals 0, and 4x minus 3 equals 0. Why did I put a 5 there? I was trying to erase with my little side button, and it don't do it on this one. Creatures of habit. How do I solve 4x plus 3 equals 0? Subtract 3. So 4x equals negative 3. And then what? Divide by 4. X equals negative 3/4. Leave it a fraction. And the other one, how do I solve for x? This one we're going to add 3. So 4x equals positive 3. Divide by 4. And x equals positive 3/4. Okay? So that one, if you were checking in your calculator, it would be between 0 and -1 and 0 and +1. Right? So it would be a skinny graph. All right. Problems like this is where people mess up a lot of times factoring. Why do you think what mistake do you think they make? Okay, it's equal to 0. So factoring, ignore the equal 0. How do you think people mess up factoring this problem? No, that's the problem. They do realize it's a difference of squares. They don't do GCF first. That's how people miss this problem. They say, difference of squares. And they don't do step 1, which is look for the GCF first. Do these two terms have a GCF besides 1? What is it? 4. So factor out your 4. So if I factor out a 4, that gives me w squared minus 9 equals. Y'all with me? Is that finished factoring? No, because in parentheses, this is a what? That's a difference of squares again, isn't it? Okay, so keep your 4 out. And what multiplies times itself to get w squared? W. What multiplies times itself to get 9? 3. Goes in the middle. Now are we factored completely? Okay, so always look for GCF first. Okay? So now, see if I have room down there. Nope, I gotta go up to top again. We set all 3 factors equal to 0. W plus 3 equals 0 and W minus 3 equals 0. Now y'all, 4 equals 0. Is there a variable there? No. And does 4 equal 0 either? No. So if it doesn't have a variable because it was a GCF and it doesn't have a variable, you throw it out. Now, you don't throw all GCFs out, just the ones that don't have variables. Y'all with me? Will, you with me? Okay. So if you have a GCF that doesn't have a variable in it, write it down equal to 0 and then just slash it through, throwing it out. Okay? And then the other ones we just solve for W. These are easy. Subtract 3. W equals -3. And this one we add 3. And W equals +3. So those are my 2 solutions. Is that good? Bum, 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 bum. All right, on number 5, they put the 0 on the left-hand side. Doesn't matter where the 0 is as long as it's equal to 0. What kind of polynomial is this? A trinomial. What do we do first to factor a trinomial? GCF. That's right. So, is there a GCF besides 1 for those 3 terms? No. So it's a trinomial, so we're going to make a table. Question, is this going to be the short way after the table or the long way after the table? How do you know the short way?
The leading coefficient.
Yes, the leading term. Could you do it the long way? Could you split the middle term and factor by grouping? Yes, and it will work, okay? But just recognize if the leading term is 1, you can go straight from table to your 2 binomials. So we want 2 numbers that multiply to get what number? And add to get what number? 11, and they're all positive, so that's good. Y'all tell me what they are. 8 times 3 equals 24 and adds to get 11, right? So 0 equals what 2 factors?
X plus 8.
All right. Is that factored completely? Yeah, I don't see any differences in squares or GCFs in that binomial. So what do we do when it's factored completely? Yeah, x plus 8 equals 0. And 8 plus 3 equals 0. Solve them. Subtract 8 and x equals -8. And on this one, subtract 3 and x equals -3. And this one will check out nicely in your calculator. All right. Well, look at this little booger. Yep. First thing we got to do before we even factor is we got to get it equal to 0. How are we going to do that? Not divide by it. Subtract 2n. Where do I put it? Where at? Yeah, you need to put it in the middle because for our trinomials to work, because these are all different terms, isn't it? An n squared and an n and a constant are all different terms. They're not like terms. So if you have that going on, then you need to make sure they go in decreasing order because your trinomial table won't work if you're not in decreasing order. So it's going to be n squared minus 2n minus 24 equals 0. Is everybody okay with how I moved all that around? Okay, so if it's going to go into, it's going to be not like terms with something, make sure you put your terms in decreasing order. All right, so now, what's the GCF of that trinomial? 2 don't go into the first term. It's 1, isn't it? So we make a table. We need 2 numbers that multiply to get negative 24 and add to get negative 2. What are they? Negative 6, positive 4. Does that add to get negative 2? Yeah, because I needed the bigger one, negative. So these are n's. So I have an n minus 6 times an n plus 4 equals 0. I know, I have to double check it every time. Yep, and then I set them equal to 0. So for n minus 6, I do what to both sides? Add 6, and n equals 6. And then for n plus 4, n equals negative 4. I'm just glad he's taking notes today. Okay. After this one, we're going to do a U-try. Okay, this was a little bit crazy. Just a little bit. Okay. 11x squared equals x squared plus 8x. We want to get equal to 0, right? So that we got to move some stuff. Now, I told y'all to move everything to the highest exponent, right? The highest exponent is squares, and I've got 2 of them. Okay, well, let's just talk about scenarios. Okay. Y'all listen to Jake. He's very intelligent over here. Go ahead, Jake.
11x squared is by itself, so move it to the right, so you don't have to move 2 to the left.
Okay, that's a good theory. But also, think about this. If I subtract 11x on both sides, that's going to get me negative 10x squared here. What do we have to do when we have a negative leading term? We got to factor out a negative 1. So that's going to be more factoring. So I'm actually going to suggest we move everything this direction. Well, we're going to subtract x squared, and it has a like term buddy, doesn't it? Yeah, so those are going to be like term buddies. So those go together. You do not do that. That does not work. That is not teaching anything or learning anything. So I'm moving everything over. So the x squareds cancel and my 8x's cancel. 11x squared and x squared are like terms. So what is 11x squared minus 1x squared? 10x squared minus 8x equals 0. Yeah, we don't want our leading term to be negative if we can help it. Okay, because that just puts a whole nother sign kink and everything. All right. So now it's equal to 0. So it's ready to factor. What's the first step to factor in? GCF. What's the GCF between 10x squared and 8x? 2x. And what does that leave me with? 5x minus 4. Very good. Is that factored completely? Yes, because 5x minus 4 is not a difference of squares. I'll come over to the side. So you got to say 2x equals 0 and 5x minus 4 equals 0. How do we solve 2x equals 0? Divide by 2. What's 0 divided by 2? 0. And then over here, you add 4. 5x equals 4. Then what? Divide by 5 and x equals what? 4/5. 2 solutions. Questions? All right, I think we got a U try. You got 2 U tries. 2 of them. Actually, it's ocho and nueve.
It always made me so mad. She's like, where is the C?
You know what makes me mad? You're not doing it wrong. You didn't factor them Do what? Mm-hmm. Yep, move everything to the highest exponent. You got to get it equal to 0 before you do GCF. Before you factor anything, you got to get it equal to 0. Hard. Full moon. These teenagers. It's springtime. Y'all are all Twitter pated. The fullness of the moon does not disappear after one night. Your mouth is always full of words. Why don't you just hush them up for a second? Technology. Let me know if y'all are stuck. Why you have it all? You didn't move. You moved everything to the highest exponent. So squared everything. So move 12x to 6x.
That's what I did.
No, exponent is the exponent, not the number in front. That's the coefficient. Yep. Good. That one says it. you get finished with both of them, discuss them with the neighbor, please. All right, y'all help me out. What did you have to do first on number 8? Subtract 12x. So you always want to go to the highest exponent. And x squared was my highest exponent. Those are not like terms. So you say 6x squared minus 12x equals 0. Right? And after you get equal to 0, you're ready to factor. So what do we do first to factor? Greatest common factor. What's the greatest common factor between 6x squared and 12x? 6x. And what does that leave you with? All right. Is it factored completely? Yes, it's completely factored. So now what do? Set each factor equal to 0 and solve it for x. So how do I solve 6x equals 0? Divide by 6 and x equals, and then the other one you add 2 and x equals 2. Raise your hand if you got your solutions 0 and 2. Any questions? Number 9, what did you have to do first? Subtract 21 on each side, and it goes on the end because it's a constant and the other ones have variables, right? So x squared plus 4x minus 21 equals 0. Now you're equal to 0, so you're ready to factor. What's the GCF of all 3 terms? 1. It's a trinomial, so then you made a table, hopefully. Multiply to get what number? Negative 21, and add to get what number? 4. What numbers did that? Positive 7, negative 3. Do y'all agree? And then, yep, the leading term was a 1, so we can go straight from table to binomials. So they are x plus 7 times x minus 3 equals 0 in either order, right? Then what? So one of them is x plus 7 equals 0, and one is x minus 3 equals 0. You do the do. And then you add the 3. Raise your hand if you got negative 7 and positive 3 for your solutions. Any questions? Negative 7 and positive 3. All right. You're amazing. Well, welcome to number 10. Okay, number 10. We're solving by factoring. What do we have to do first? Yeah, we want to get equal to 0. So move x squared is the highest exponent, so we're going to move that 35 and subtract it on each side. Very good. And it's a constant. Don't have any variables. Very good. So 2x squared minus 3x minus 35 equals 0. First, we look for the... Yeah. Is there a greatest common factor besides 1? No. Then we see that we have 3 terms, which is a trinomial, which means we make a table. Short way or long way this time, y'all? Long way. So, we want 2 numbers that multiply to get what? No. Negative 70. 2 times negative 35. And then we're going to add to get what number? All right, let's think about this. We need a negative and a positive, and the bigger one's going to be a negative. Negative 10 and positive 7. Y'all agree? Yeah. It's his birthday. He knows it works. He's wiser today. Right? Okay. So we're going to split the middle term. I want my plus sign in the middle, so I'm going to do it in this order. So 2x squared minus 10x plus 7x minus 35. Don't forget your equals 0, or you can't drop your equal sign in an equation. You got to have it all the way down. That's right. So now I do factor by grouping. So he's drunk his math juice. Yeah, it has an 8 in it. There you go. And a variable. Look at it. Took that math juice. All right. What's the GCF in the first group? 2x. Good. And what times 2x is 2x squared? Minus what times 2x is 10x? Good. Plus, what's the GCF in the next group? 7. And what's that leave me with? Equals 0. Keep that equals 0, y'all. All right. Now, what are my factors? Good. All right. So, are we factored completely?
No.
Well, we factored completely.
Yeah.
Yeah, then now we got to solve it. So, set them both equal to 0. We're not done with the problem. You haven't found the solutions, but you have factored it all the way. So, we just like to hear ourselves, right? Just rolling with it. All right, so if I were checking this one in the calculator, I would have plugged this part in for the y equals, right? And then it should cross the x-axis at 5 exactly on the integer. And negative 7 over 2 is the same thing as what is a mixed number? Negative 3.5. So it'd be halfway between negative 3 and negative 4 if you were looking at the graph. Good job. Y'all, that right there is probably the most, it was a lot, took up my whole screen. But that's probably as most difficult as it could get, honestly. I know. See, there you go. They're not that bad. You're just doing what you did yesterday, except you're equaling it to 0 at the end of solving.
I don't know why, but I like it so much.
Aww. All right, number 11. Number 11. Okay, I'll just go ahead and tell you, this is a problem like one that I have put on the test for years on factoring, and it always gets missed. Can somebody, it's already equal to 0, can somebody tell me why you think it always gets missed? Because they don't do the greatest common factor first. They just start with their table and they go, or they factor out the greatest common factor and don't keep it all the way down. Okay? So what is the greatest common factor? X is the greatest common factor because everybody's got an X. Well, you know, everybody in this problem has an X anyway. So we're going to take an X away from everybody. That'd be nice. Okay. Now, in parentheses, the GCF is 1, and it's a trinomial, so we're going to make a... Now, when I do this table, short way or long way? I didn't, did I? My bad. It's just supposed to be 3x. Thank you. Thank y'all. Thank y'all. I know. All right. So now we make a table in parentheses. I want numbers that multiply to get what number? And add to get what number? What are they? -7 and +4. Okay, so we said we could go straight to our binomials because the leading term in that parentheses is a 1. Don't forget your x. Or your variable, whatever you want to call it, okay? keep your GCF. If you leave off your GCF, it's not going to be correct because this one has 3 solutions. Bless you. You need a warning on yours. Okay. So, you got to include the GCF. It is. All right, y'all stop talking. Yes. Sorry, I left off the plus. All right, so now set all 3 factors equal to 0, even the x. If you leave off that x equals 0, it will be wrong. Okay? Now, x equals 0, we don't have to solve that, right? But circle it because it's one of the solutions. You don't mark it out. We need it. It's one of the solutions. This one is crossing the x-axis 3 times. Okay? If you don't believe me, you can graph it. And then we solve the other ones. We actually have to do a little math. You add 7. 7. Yeah, so this one has 3 solutions. Can I give y'all a clue? Most of ours have had 2 solutions, right? This one has 3. What was our highest exponent in the original problem? Okay. And that one, the highest exponent was a square. How many solutions did we get? Now, let me just say that. Okay, let me say this because I don't want to lie. I do not lie about math. I can't do it. Like my kids, when we're counting backwards, we don't stop at 0. We go to negative numbers because numbers don't need a 0. Okay, that's how stickler I am about speaking correctly about math. Okay, so this tells you how many possible solutions there are. Now, in Algebra 1, we are only talking about real solutions, okay, for the most part. In Algebra 2, you will have imaginary solutions as well, okay? Okay? So, the majority of the time, that will tell me how many solutions there are. However, if you have like a perfect square trinomial situation going on, you will just have one solution repeated. Does that make sense? So the only exception is if you have like a perfect square trinomial. All right? Something that's repeated. All right? So for the most of the time, the highest exponent tells you how many solutions you should expect. Possibly. All right, number 12. Look at that one. Well, I got 2 squares, don't I? 2x squares. So which one do we want to go to? Yeah, which one's going to make it not negative? Yeah, so let's bring the x squared to the 5x squared. So subtract x squared. All right, and now what? I subtracted the x squared. Now what do I need to do? Where do I put it? Does it have a like term, buddy? No, but it's a constant, so it's going to go in the back. Okay. So what is 5x squared minus 1x squared? Minus 2 equals 0. And now we're equal to 0, so we can start factoring. So it's a what kind of polynomial? Trinomial, so we need to make a table. Is this going to be short way or long way? Long way, but we can handle it. We want to multiply to get what number? Negative 8. And add to get what number? 7. Negative times a positive with the bigger positive. What are they? 8. Negative 1 adds to get 7. Right? Well, if I could try 4 and negative 2, but that's not going to add to get 7, is it? No. So it's got to be 8 and negative 1. So 4x squared, I want to put the plus in the middle, so I'm going to say minus 1x plus 8x minus 2 equals 0, just because I'd rather have a plus in the middle. Sometimes you can't avoid it if you have 2 negatives. Group and group. What's my GCF in my first group? And that leaves me with 4x minus 1, very good. Plus, what's my GCF in my next group? 2. What that leaves me with? close parentheses equals 0. What are my factors? Mm-hmm. Factors completely. Yes. How do I find my solutions? Set both factors equal to 0. So 4x minus 1 equals 0. And 2 equals 0. 1/4. Yep. I got room. I thought I was out of room. And then 2. X equals negative 2. So I got 1/4 and negative 2. Questions? There must be a reason I want y'all to do 13. So let's do it. This is our last example. And I'm just, y'all, I mean, it seems like a long lesson, but I wanted to show you like as many different scenarios as you might see on that practice, okay? So I was just trying to help you, not trying to kill you. Trying to help. I do too. I think it's fun. Yeah, first of all, what's the GCF between all 4 terms? It's already equal to 0. GCF is 1, 4 terms, so we automatically do what? Grouping. Yeah, we'll work around it. We're good. All right, what's my GCF in my first group? M squared. Parentheses. What times M squared multiplies to get 3M cubed? 3M plus what times M squared is M squared? 1. Copy the minus in the middle. And what's our GCF in the next group? Just 1. Now this is a negative 1 though, so you're going to do opposite signs. So what multiplies times negative 1 to get negative 3M? Positive 3M. What multiplies times negative 1 to get negative 1? Positive. And if you get confused on this, know that they're supposed to be exactly like that one, right? I mean, that's kind of the cheating way, but you get it right. Right? Equals 0. So what are my factors? 3M plus 1 and M squared minus 1 equals 0. Is that factored completely?
No, there's a difference of squares.
Uh-oh, what's up with this? It's a difference of squares. So y'all little work-aheaders are erasing. I love teaching honors kids. They try to work ahead all the time. All right. So, yeah, 3M plus 1 is not a difference of squares, so we're going to keep that one like it is. But M squared minus 1, everything's a square and there's minus, so you're going to break that into more binomials. What multiplies times itself to get M squared? M. Put them in the front. What multiplies times itself to get 1? Put them in the back, and what goes in the middle? A plus and a minus. Now are we factored completely? And y'all, clue, what was our highest exponent? So that means we need 3 solutions. So 3M plus 1 equals 0. 1 equals 0. And M minus 1 equals 0. So for the 3M plus 1, we subtract 1. So 3M equals negative 1. Divide by 3. M equals negative 1/3 is one solution. And the other ones are simple. Yep. So, yeah. So those last ones probably as difficult as they will be. So that is the end of notes for today. We're going to take out our practice now and work. Have a good day.